is y is 1-to-1 function for x or of x. So you're basically asking for no duplicate y's. So what a horizontal line test is, and the way you do this was with the horizontal line test. And you can only have one point that goes through the horizontal line. So a fail is greater than 1 point on the line, and a pass is only 1 point on the line. So just anywhere down here, we have a point that happens 1, 2, 3, 4. So that's a fail. Another example of the fail can be like right here on the horizontal axis of x. So this is 1, 2, 3 fails. So this is does not define. Of x and y is given to determine if the relation defines y as 1-to-1 function of x. So we're looking for duplicate y's. So we're just going to read these off. Negative 4.4, there's only one of those. 7.7, only one. 4.6, only one. And negative 2.4, there's only one of those. So this is 1-to-1. Graph of a function is given. Graph the inverse of the function. This is going to be multiple choice. So you have f and then you have inverse. So this is the function. And then you have the inverse function with this notation. And the way that you pick points, I would say x-intercepts, y-intercepts, and then if you look at this graph, it's pretty faint. But you want to pick a point that goes to like the corners, right? Like with this one, it's 4, 2. So I have 0, negative 4, 1, 0, and 4, 2. That's going to be what we have for the function. 4, 2, 1, 0, 0, negative 4. Doesn't matter the order. And remember, the inverse is going to switch domain and range. So this column becomes that column, and this column becomes that column. So instead of 4, 2, I'm going to have 2, 4. Instead of 1, 0, 0, 1. And then 0, negative 4 is negative 4, 0. So we're going to plot those points, 2, 4. Let's use a different color. 2, 4, 0, 1. And negative 4, 0. And then you're going to draw an arc that goes through them. And you want to recall, it's not perfect, but it'll do the job. You want to recall that this is the identity function. I cannot spell identity. And this is also called the line of symmetry. And it's y equals x. So they're going to be about the same distance from each other, from the line of symmetry, and they're going to look like mirror images. The top is going to reflect the bottom is going to reflect write the domain and range and interval notation. You're going to graph the function on the table. So all we need to do is put this into Desmos. And this is for the x-intercept. Another thing I want to talk about here is that where y equals 0, that's going to be your horizontal asymptote. Let's see. We can see it more right here. So our line never touches that horizontal asymptote. That's how you know that it's yes when it never touches it. So that's a boundary. So that's going to explain our range. So the range is going to be from 0 to infinity. And the domain is negative infinity to positive infinity. Let's do the formula. A equals P times 1 plus the rate as a percentage, no, as a decimal over the number of times something is compounded, and then with the exponent, the number of times something is compounded times the time in years. So if I read over this, I have 14,000 is invested in 3.5% interest over 9 years, compounded quarterly. That means how many times it's compounded in a year, and that's going to be 4. So quarterly means 4. And then you want to do 2 decimal places. So it's $19,157.36. It's continuous. So 14,000 invested 3.5% interest for 9 years, compounding continuously. That means our formula is going to be A equals P times E raised to the RT exponents. Let's see. So that means our formula is going to be P equals 14,000. If you can continue reading it, what is the resulting value? It's just asking what the numerical value is. So the rate is going to be 0.035. I got that by saying 3.5 divided by 100. And then the time was 9. And then it's continuously compounding, so it's going to say E is E. So in this calculator, you have to type in the letter E with your keyboard. So 14,000. And then there's no multiplication, or it's actually P times E, 14,000 times E. So go to your keyboard, type in the letter E, go back to your numeric keyboard, and then raise it by 0.035 times 9, which is the number of years. And our answer is $19,183.63. Remember, it's 2 decimal points, right? Because it's money and then the decimal with 2 digits. Here is just to switch the argument and the exponent. So you just want to switch those two. So you're going to get x to the n exponent equals m, which was the argument. This is always going to be the base. And I looked for the x-intercept, and then I substituted a number in here. Whatever the base is, you're going to substitute for x. So I did log 8 of 8, and then I got the output of 1. Denominator, I make it, because it's quotient, those bottom, so this is the numerator, right? And then those bottom terms are the denominators, but you're going to make them the second and third term. So this is going to be the first term. This one's going to be the second term. And this one's going to be the third term. And then you want to keep the negatives in front because you're going to have to distribute that negative. So we're going to do this all in one step. This is quotient and power. So it's going to be log 2 P, and then we're going to bring that 3 to the front, minus 5, because this goes in front, that one in front, log 2 Q minus log 2 R. The whole thing is our solution. Or solve the equation, simplify the answer as much as possible. We're going to want to change to a base of 4 here. So we need to change this. So I get 4 to the 0 equals 1. 4 to the 1 equals 4. 4 to the second equals 16. 4 to the third equals 64. So this replaces that. I'm going to rewrite the equation. I have 4 to the negative 3w plus 18. This whole thing is an exponent. Equals 4 to the third because they have the same base, the bases can be crossed out. And then we are only concerned with what the exponents equal. So negative 3w plus 18 equals 3. Solve for w. Minus 18 from both sides. Negative 3w equals negative 15 divided by negative 3. W equals 5. Solve the equation, write the solution set in exact values. That's important. Given the terms of a common or natural logarithms, we're going to use ln here and then give approximate solution for decimal places. So if you notice, this is going to be your answer, but so we have to fill in right here and right here. So this is the approximate. For decimal places. Okay, so we have 1302 equal 13r plus 7. Subtract 7 from both sides. 1295 equals 13r. So we're going to do ln of both sides. Ln is its own number. So ln 1295 equals r ln of 13. Our goal is to isolate r by itself. So then I'm going to divide both sides by ln of 13. So ln 1295 equals r ln 13 divided by ln of 13. So you're going to keep ln 13 as its own number. This goes away. Our answer is r equals ln 1295 divided by ln of 13. That is an exact solution or exact value. The text and test interchange those statements as equivalent statements. So ln 1295 divided by ln of 13. That's a 9. This approximates to, you just put in the calculator, 2.7939. Says write the solution set with exact solutions. Okay, it's 1-to-1 because we can get rid of the ln's on both sides. So then I'm just left with 9x plus 4 equals 8x. So remember that these are the arguments, and the arguments have to be positive. So arguments are greater than 0. Arguments are positive. That's even after we substitute the value of x into the argument to check our solution. I'm going to subtract 9x from both sides. So this is 4 equals negative x divided by negative 1. It's the same thing. X equals negative 4. So now we have to check our solutions with our first argument. X equals negative 4. So I have 9x plus 4. 9 times negative 4 plus 4 equals negative 32. That does not work in the first argument. That's our only solution. So most likely it's not going to work in the second argument, but we could just show the work. This is not necessary for the test or the final exam. So the solution set is called the empty set. This is an answer. This is called empty set, which means no solution or undefined. You get undefined from your calculator. Okay, empty set. So if someone's asking you, hey, what's the answer to that? This is the answer. Solutions. This is also 1-to-1. We just delete that. So we're going to get z squared plus 3z equals 18. We're going to want to bring the 18 over because we have a quadratic and we want to factor. So we have z, it's 18, so z plus 6, z minus 3 equals 0, z equals negative 6, z equals 3. We have to check our solutions in this argument right here. Should work out for both though. So we're z equals negative 6. I get z squared plus 3z. Negative 6 squared is 36. Plus 3 times negative 6 is negative 18, so I get 18. That one works. Let's also try for z equals 3. Z squared plus 3z. Those base, when it's squared, that right there, oops. That right there, that base, needs to be in parentheses. Always. It just has to be in parentheses. Don't make that mistake. So I have 3 squared and 3 times 3. So I get 9 plus 9 equals 18. So this is also, so it's got to be in set notation, negative 6, comma 3. Does not matter what number comes first. This is the answer. Here's what you're going to do. It is implied that this has a base of 10. So all you need to do is switch the 1 to the expression and the 5x minus 5 is argument. So it's 10 to the first equals 5x minus 5. Solve for x. Plus 5 to both sides. So it's 10 plus 5 is 15 equals 5x divided by 5. X equals 3. And that solution works out when we check it. Set, what is that solutions? So this is 1 to 1, but this right here is going to be the product rule. So you're going to have to multiply those, and then you're also going to solve for x. So these logs go away. So you're left with, I'm just going to do the work up here because I'm running out of space. X times x minus 14 equals x minus 44. X squared minus 14x equals x minus 44. We want to subtract the x and add the 44 to both sides in one step. X squared minus 15x plus 44 equals 0. We're going to factor. So it's x minus 4, x minus 11 equals 0, x equals 4, x equals 11. These are both positive, but we have to check for each argument. If it's not in parentheses, it's still an argument if it's a variable. So we have to check the argument, each value for all 3 arguments to be positive. So where x is 4, x equals 4, that one works. Where x minus 14, 4 minus 14 is negative 11. That's wrong. So that's automatically not a solution. So let's start again for the x, where x is 11, right? And x, that one works. And then x minus 14, where x is 11. So 11 minus 14 equals negative 3. That is not going to work. So neither one of these is a solution. That means that there's no solution set. And that right here, this is called the empty set. That's the solution. That's the form. But first you need to use product rule. And it's going to be product rule and then exponential form. And then solve. Then you're going to have to test your solutions in the arguments. Arguments can't be negative. So it's going to be n minus 5. It's going to be log 3 n plus 5. No, n minus 5. N plus 3 equals 2. So log 3 of the quadratic n squared minus 2n minus 15 equals 2. So then it's 3. So you switch these, right? 3 squared equals n squared minus 2n minus 15. 9 equals n squared minus 2n minus 15. Subtract 9 from both sides. 0 equals n squared minus 2n minus 24. N minus 6, n minus 4. All that equals 0. N equals 6, n equals 4. So now we have to test them in the argument there. So we're n equals 6. Let's do that. N equals 6, n minus 5, n plus 3. 6 minus 5 is 1. That one works out. 6 plus 3 is 9. That one works out. So n equals 4. 4 and minus 5. So 4 minus 5 is negative 1. That does not work out. Not a solution. The only solution is going to be 6. Okay. This is the numerator. This is the denominator. It's equal to 2. And then you're going to do the exponential form. And then you're going to solve for x and then test your argument right here. So I have log of 4, 5 over t plus 6 equals 2. This whole thing is the argument. So you're going to switch these two. So it becomes 4 to the second equals 5 times t plus 6. Then you're going to cross multiply. Remember that 4 squared is going to be over 1. So then I have 16 over 1 equals 5 times t plus 6. Leave that in parentheses. So 16 times t plus 6 equals 1 times 5, which is 5. 16t plus 96 equals 5. Minus 96 from both sides. 16t equals negative 91 divided by 16. T equals negative 91 over 16. That's my solution.